Okay, here is a sort of classic, a great starting question to learn about the coefficient of friction. When I solve these, I'm always going to start with the free body diagram and then figure out what I can from there. So for this one, we've got an applied force of 20 newtons. It says there's a coefficient of friction, so I know there's going to be a friction force, and I'm asked to find the acceleration. So my free body diagram, I can't get away from gravity, so I'm going to draw my gravity first. The question doesn't say anything about this trampolining in the air or in free fall or in an elevator or something weird. So I know that the normal force has to be the same. Usually I kind of split it up, and then the vertical component, I know it's not accelerating. I know there's not a whole bunch of forces, so that's what I'm going to call what I call the boring case. Really what that means is that the normal is equal to gravity. Gravity is always m times g. In this question I made up, the mass was 3 kilograms. So I know that the gravity and the normal are both 3 times 9.8, which is 29.4. So I know that the normal, we'll need that later. The normal is 29.4. Okay, back to my free body diagram. It's being pushed forward with an F applied, and we were given that number. It's 20 newtons. And because of the coefficient, I know there's friction. Friction is always in the opposite direction, so back there. I'm going to put it together and then figure it out, but you could find the force of friction on its own right off the bat. Just do that off to the side. Well, you'll see what I'm going to do. In the horizontal component, we've got a tug of war, so I'm going to set up F net equals ma. The force that's winning the tug of war is Fa. The force that's losing the tug of war becomes negative. It's Ff, and that's equal to ma. I'm going to do one more line. From what we talked about in the note, I know that Ff is always mu times Fn. That Greek letter, it kind of looks like a U, but it's the Greek version of M. We pronounce it as mu. If we had a graph, it'd be the slope of the Ff versus Fn graph. Moving forward, it's just a number. It'll be either given in a question, or the point of the question will be to figure it out. For this particular question, we were told that the F applied is 20, and I got to scroll back up for a sec. The coefficient of friction was 0.5. So Fa was 20 minus the coefficient of friction was 0.5. Then we did this math over here to get that the normal force was 29.4, so I subbed that in. And in the question, it said the mass was 3, so that equals 3a. Now I've got a linear equation. I know everything but the a, so I can just do some algebra to figure it out. Oops. 0.5 times 29.4, it's going to be really close to 15. When I tried it, I got 14.7 on my calculator. 20 minus 14.7, that's going to be close to 5. And then divide the 3 over, 5.3 over 3, I got 1.77. I'm okay if you just leave it that way. The way you set it up, I can tell that you know that it's positive. So the answer to my question, if you put an applied force of 20 on a 3 kilogram object, if the coefficient of friction is 0.5, then that object is going to accelerate at 1.77 meters per second squared. That's how we'll use the coefficient. Whenever a question involves the coefficient of friction, you have to take a bit of time to find the normal force, and then use the normal force to finish the question, whatever the question happens to ask for. All right, email if you have any questions.